Hi. Hello, everybody. Good morning, good afternoon, good evening. This is according to where you are. Thank you for making the time. I know 30 minutes, it's a lot on Thursday. It's a real cost. Thank you for that. My name is Tamer Wagih. I have spent 25 years in cybersecurity, in IT, in cybersecurity, governance, secure architecture, privacy, AI and AI security lately. And I want to spend the next half hour on something that have been bothering me for about 2 years. It's about the AI. There will no be there will not be an agenda for this webinar, not because I didn't make it, but I wanted you to make the follow that I'm using. So I want to describe the deployment that that is already existing to you. And what is prescribed? What about it? What about this? This is an illustrative component. This is assembled from published vulnerability classes, not a reported incident. And it is drawn from my it is not drawn from any of my systems that I am responsible for, to be clear for that. Here is that we have. It's the architecture view, the threat model, the SAST, DAST, penetration testing, identity access management review, change approval, data loss prevention. 8 gates. Those 8 gates needs 8 controls, 8 approvals. Every single one of them working exactly as designed, exactly. Nothing in this list was designed to see what happened next. So now I have a question for you. Can you name every AI system running in your organization right now, including the ones that arrived as a feature in software you already owned? There is a poll you will find. Please give me your answers. I think I didn't see the poll. So let us start. This is the Act 1. This is the perimeter error. This is to understand the gap, we have to go back twice. This is for the perimeter that we have, the perimeter era, and the poll is in the chat. If you find it, please reply to the question that I was asking. And now the perimeter assumption. This is a perimeter era. We knew where everything was. This is the first thing. Our data centers, our network, our endpoints, our applications. And because we knew everything, where it is or it was, we could draw a line around it. Inside was more trust than outside. We are trusting the inside than the outside. This is what we are thinking of. So we built a firewalls, segmentations, intrusion detection, intrusion prevention, VPN, endpoint protection. There is 3 verbs: protect the boundary, control entry, monitor activity inside. That model wasn't perfect, but it was aligned with the architecture it was built to protect. So then the architecture moves to the cloud era. We started for a cloud, the cloud assumption that we have. We stopped owning the infrastructure. It's someone else. Shared responsibility, APIs, distributed services, software defined, everything. And the boundary stopped being a place. So identity became the primary control plane. Not the only control, but there is data, workloads, and configuration, all matter. But identity became the thing we governed first. So identity access management, PAM, MFA, posture management, DevSecOps, continuous compliance. The 3 verbs for govern identity, secure configuration, monitor continuously. We notice that what actually happened there, the architecture changed. So the assumption changed. So the control changed in that order. The AI era, and moving to the AI era, the 3rd era. Here is where it gets uncomfortable for us. Here is the environment for the AI actually contains the models, the prompts, system instructions, embedded systems, retrieval, agents, tools, integrations, AI features sitting inside software. You are already own and already paid for. That column, the operating environment, I can feel. It already fills. These 2 columns, I can't. And not because I don't prepare, it's because an industry, we don't have settled answer yet. And this is the gap. Look at the bottom, what we have: govern, blank, 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 and continuously. I'm going to fill those gaps before we finish, but not yet. Because if I fill them in now, you will write them down and nothing will be changed. We'll start with, to fill those blanks, we need to be precise about what AI actually is inside an enterprise. AI is not an application. AI become enterprise operating layer. AI is not a standalone tool anymore. Look at where it actually acts, actually sits. It's customer experience, analytics and decision support, knowledge and content, software development, cybersecurity operations. Your SOC, your Security Operations Center, very likely using it already. Business and operational workflows, 6 functions, and they don't each have their own AI. They are share one layer. Same model, the same data, the same prompts, the same retrieval, the same agents, the same tool. Every one of those functions depends on it, which means when AI becomes part of the enterprise operates this, the AI becomes enterprise risk. Here is why a shared layer matters. You have a shared retrieval corpus, policy documents, manuals, and knowledge base, ticket history. Something enters it that shouldn't. There is no provenance tier. There is no trust boundary. A document is a document. And then every function that queries that corpus inherit the result. The dependency is shared. So the failure is shared. One corpus, many consequences. Now, one thing before we go further, because it matters, half of what I'm going to show you, it's not an attacker. Or I can say some of it is an attacker, and some of it we built it. Some of this adversarial is poisoned corpus, injected instruction, compromised tool, and the things that we built it, stale retrieval, overbroad permissions, unvalidated output, a confident error. Both of those AI risks, if your AI risk register contains only the attacks, you have a half risk register. And this is not one industry's problem. Government services, caseworker assistance that reads regulation, policy and guidance to determine citizen entitlement, banking, know your customer, and AML, anti-money laundering, Copilot that summarizes adverse media and screens it screens it against sanctions, list of internal policy, healthcare, a clinical documentation assistant that retrieves from formally protocol and policy documents and it drafts into the record. Critical infrastructure, a maintenance, planning against a maintenance agent, planning agent that reads vendor manuals and writes work order into the operational system. This is 4 sectors, 4 different regulators, 1 identical architecture. Retrieve untrusted content, reason over it, act through a tool with standing credentials. So let's ask ourselves what the architecture does to security. What that architecture does to security. I want to give you a framing, and I want to be straight with you about it. This framing is mine. It isn't a standard. You won't find it in a document anywhere. The mechanisms, the mechanics underneath it are not mine. Those are documented, and I will show you exactly where. Security has always answered 4 questions. What comes in? What did we build? How do we know it? How do we know it works? And what it can do? What can it do? Every framework you own is an answer to one of those 4. AI rakes all 4 answers. Not one of them, all 4. So what comes in? The answer that always worked, that code is trusted, data is validated, and the boundary between the 2 is enforceable. Everything we build sit on that. Input validation, OWASP, Open Web Application Security Project, Web Application Firewall, WAF, API, gateways. Every one of those assumes you can tell the difference between an instruction and a piece of data. We can do it. A language model can't. An instruction and data arrive in the same channel, and the model has no reliable primitive for separating them. and it's only about what a user types. Its content, the system retrieves on its own without anybody asking. OWASP, Open Web Application Security Project, calls this prompt injection. It's a number one of their own OWASP top 10 for LLM application, large language model applications. And could you please read with me their wording? They are saying, treated as mitigated, never eliminated. This is their wording. That makes it a residual risk with compensating controls, not a closed finding. And this is one of the areas for auditing community. What did we build? The answer that has always worked, that the artifact is source code. We read it, we scan it, we differentiate it, we put it in SBOM, software bill of material. That's 20 years of application security, and it works. Now, the artifact is weights and corpse. There is no source to review. Behavior is emergent. Nobody wrote it. Third-party models are opaque by construction, and the vendor can change the model underneath you without asking your permission. But here is the one that usually stops. Your SBOM software bill of material has no row for a retrieval corpus, no row for a fine-tuning set, and no row for an AI feature that got switched on inside SaaS, software as a service. You already licensed it. Model cards, provenance, attestation, data set documentation, all of that is real and improving. The gap is narrowing. It is not closed. How do we know it works? Same input, same output. That's the assumption. And because of that assumption, a passing test is evidence that a control operates efficiently. That is what test-based assurance means for us. And that is what a point-in-time certification means. Non-deterministic systems break the chain. And look at what it takes with it. 3 of the 8 gates, 3 of the 8 gates I opened with SAST, test, penetration test. Those aren't 3 controls. You don't get proof over a case. You get statistical confidence over a distributed or over a distribution. And those are not the same thing. And an auditor will eventually ask you which one you have. Believe me, the auditors do. So continuous evaluation replaces point-in-time testing. And I want to be precise about that because it's easy to hear it wrong. That is a different operational model. It is not a bigger test suite. And your assurance has to survive a model version change that you don't schedule and you cannot refuse. This is for SAST and DAST, the pen test that I was talking about. What can it do? Identity belongs to human and deterministic service account. Authority is stable and predictable. Identity access management, PAM, least privilege, separation of duties, every one of those assumes the thing holding the credential behaves the same way every time you ask to it. Now the system acts. It holds credentials, it calls tools, and its next action is influenced by untrusted content that it is just finished reading. That is the moment an information risk becomes execution risk. And I would ask you to sit that sentence with that sentence for a second, because it's the whole difference between a chatbot and an agent. Least privilege for a non-deterministic actor is not a configuration setting. It's unresolved design problem, which is why if you asked me for the first control I'd mandate, it wouldn't be a filter. It would be hard authority boundary at the tool layer. Look at these four together. Question one. What comes in is partially a runtime problem. Filters, validation, output handling. You can improve it after go live. The other three, you can't. Model choice. Corpus and provenance are fixed before go live. Your evaluation, harness, and your logging have to be built in, not bolted on. And authority boundaries are architecture. Retrofitting them means re-architecturing. 3 or 4, which is why we will add governance later, isn't a schedule decision. It's an architecture decision. And you are making it either way, whether you decide to or not. That's the argument. One system, 4 failures. Now let me show you all 4 failings at once in one system in about 4 minutes. And again, no ambiguity. We will follow the construction illustration. Here is the system. A case worker asks a question. An assistant, a model with a system prompt, it retrieves from a corpus of regulation, policy, and guidance. There is a tool layer holding service credential and a case management system, the determination and the case record. There is nothing wrong with this diagram. It passed architecture review. That's the problem. And notice something. It's the same 5 boxes at hospital, at bank, and the maintenance agent, retrieve, reason, act. The path for it, 5 steps. 1, a document gets added to the retrieval corpus, and it contains an instruction shaped text. And I wanted you to stop with me on that for a second. There is no exploit here. There is no malware. It's a file. Somebody uploaded a document. Step number 2, retrieval surface that document as authoritative context. The corpus has no provenance tier and no trust boundary. As far as the system is concerned, a document is a document. 3, the model treats that retrieved text as an instruction rather than as a data and widens the request. 4, and this one is the one that matters, the agent executes using its own standing credentials. No pre-action authorization, no human checkpoint. This is a step where an information risk becomes execution risk. Number 5, the output is rendered and acted on without validation. Either personal data crosses a boundary it shouldn't, or determination gets issued on the wrong basis. And a determination that has already been communicated to a citizen is not something you quietly issue. 5 ordinary steps, and every single one of them sits inside normal authorized behavior. So what did the SOC, Security Operations Center, what did they saw? Same 8 controls we started with, the same architecture review, threat model, SAS, DAS, penetration testing, IAM review, change approval, and data loss prevention. Nothing failed, nothing fired. And the dashboard was accurate, mashallah. An authenticated service account made an authorized API call. That is exactly what it looked like, because that it is exactly what it was. That is the gap. It isn't a missing control. It's a correct control, measuring the wrong system. Not a control failure. It's a scope failure. Sorry. Did you see it now? Is it back? Okay. Matt, for the record, and so this slide survives being forwarded without me. There is a mapping. Here is a mapping. Each step, the broken answer is exploited. And the documented class, it belongs to supply chain and poisoning, vector and embedding weakness, prompt injection, excessive agency, improper output handling, and sensitive information disclosure. All of that is in the OWASP top 10 for large language model applications, which means every single one of these is already in guidance you own. Nobody had to discover anything today. The control gap. Your controls was not wrong. They are scoped to a different system. In this slide, I wanted if I were setting where you are now. So let me say it upfront. It is designed to be a screenshot. If you please, if you wanted to take a screenshot of it, please go ahead. Be my guest. There is 6 controls you already run, what each one still covers, what it doesn't cover, and the 4th column, which is the actual point, what supplements it. I'll speak to 2 of them. I am PAM, Identity Access Management, Privilege Access Management. It still covers human access and deterministic service accounts perfectly well. Nothing has changed there. What doesn't cover is non-deterministic actor holding standing credentials. What supplements it? Pre-authentication authorization, scoped ephemeral identity, and a human checkpoint on anything irreversible. And the change management, it covers code and configuration releases. It doesn't cover corpus updates, prompt change, or model versions, including your vendors. Your provider can change the model underneath a system you certified last quarter, and your change process will never see it happen. Column 4 is a point. Without column 4, this slide is compliant. Is a compliant. With it, it's a plan. The gap is identical across all 4 of those sectors. The consequences isn't. Government service, citizen entitlement, decision, administrative law, and the right to a reasoned decision, banking, financial crime exposure, regulatory sanctions, and decisions that have to be explainable to a supervisor, healthcare, patient safety, regulated health data, and clinical decisions that a human being is accountable for. Critical infrastructure, physical safety, operational continuity, and actions that cannot be undone by rolling back a database. 1 architecture, 4 regulations, 4 completely different worst days. Which is why this is an architecture question before it is a compliance question. So we are not moving too fast. We are measuring the wrong system. The frameworks, or here is the good news. The good news is you don't need a new framework. You need the ones that were written for your problem or for this problem. We have NIST AI RMF risk management framework has 4 functions: govern, accountability, roles, governs for accountability, for roles, policies, culture. Second one, map for context, intended use, inventory, impact. Measure for evaluation, metrics, monitoring. Manage for prioritize, respond, recover, decommission. Map addresses the artifact question. Measure addresses the assurance question. Manage addresses input and authority. And govern sits across all four governance. Then there is two standards. ISO IEC 42001, it's the management system, AI management system. Who is accountable? How it operates? How it gets reviewed? And is it certifiable? The second standard, ISO IEC 24005. In this one, the one that most people in this room want to have heard of, maybe. And it's the one I would point at. It's the AI System Impact Assessment, AI SIA, System Impact Assessment. And that is what built in from the beginning actually looks like as a deliverable with an owner and date. So one regulation, I have mixed room today. So let me not read you a list of things that don't apply to you. But here in Kingdom of Saudi Arabia, we have SDAIA. SDAIA, Saudi Data and AI Authority. They have AI ethics principle. They have PDPL, Privacy Data Personal Law, and it's implementing regulations for personal data. NCA, National Cybersecurity Authority, Essentials Cybersecurity Controls, we call it NCA ECC, which an AI system inherits likely any other systems, and NDMO, National Data Management Office, for data governance and classification. For internationally, we have ISO 24001, NIST's AI Risk Management Framework, and of course, EU AI Act, binding, and also a risk tiered. Here is the useful part. They are all asking you the same three things. Know what AI you run, assess impact before deployment, and keep a named human accountable. None of these three requires a regulator to pick a technology. All three of them are auditable today. "20 minutes ago, I left 3 blanks. If you remember, govern and blank, blank, blank. Let me fill them. Perimeter, protect the boundary. Control entry, monitor. Cloud, govern entry, identity, secure configuration, monitor continuously. And AI. Here it is. Govern authority. Constrain context. Evaluate continuously. Governing authority, that's the question, that's question 4, what it can do, constraint context. That's question 1 and 2, what comes in and what we built and evaluate continuously. That's question 3. How we know it works. 3 verbs, not a tool list, not a vendor category, 3 verbs. For practically 90 days from as a solution from day 1 to 15 inventory, every AI system, including the features inside software you already own, a register with owner, purpose, data classes, and autonomy level. For 15 to 30, triage on 2 axes. How autonomous is it and how consequential? Hard gate on anything that acts at a high sequence. 30 to 60, impact assessment, top tier only, not everything. 45 to 75, authority boundaries. From '60 to '90 evaluation and logging. Every row there has an owner and an evidence artifact deliberately, so you can assign it and track it to closure rather than admire it. And the order matters. If you start with controls, you will secure the wrong system beautifully. Three things to take with you. 3 things. AI is an enterprise operating layer, not another application. Your controls are not wrong. They are scoped to a different system. And 3 of 4 broken answers are decided before deployment, which is why governance cannot be retrofitted. One ask, start the inventory this week. Everything else depends on it. Thank you. Now I'm finished and I would like to take your questions. Does anyone has a question? Yes, go ahead. Jay Ismail, you are raising your hand. So, Maher, you are raising your hand. You have one question. Please start. So slide 23. Yes. Okay. If you have any question, please write it in the chat. Yes, I return back for slide 23. How can organizations identify risks when using third-party AI tools like ChatGPT or Copilot? Okay, if you are following the steps that you are having, those ChatGPT or Copilot, has to be in your inventory, and you can use the guidance from NIST AI Risk Management Framework for ISO 24001, 24005. As I said at the end, it will mitigate the risk. We are not eliminating it as we are saying before, only mitigating the risk. If you are classifying your data, you can know what data will be uploaded or not. If of overall, in the beginning and till the last, if you have a governance, a proper AI governance inside your organization, definitely you will mitigate the risk in a very proper way. What, Jomerin, I hope this answered your question, Meher. For J. Ismail, what will happen if no inventory done for assessment? If there is no inventory done, how could you know what did you have? How could I protect you? If I didn't know that I have this kind of software or application, that it is AI or using AI. And me as a cybersecurity, I don't know. How could I protect it? You have to have, it's mandatory. That's why I'm getting it first. You need to know your inventory. You need to do it properly so you can know what you have and prioritize it, make prioritization to it. After that, you can accordingly the controls, security controls to protect it. Ayman, how AI governance fit within organization structure? Is it cybersecurity department responsibility or should be separate? Good question. AI governance, if we are talking about governance, we know now it's that AI is part of enterprise risk. So both are working together. Enterprise risk management for the enterprise level, and we for cybersecurity are doing our AI governance level, because we have NEST AI risk management framework, the enterprise level cannot, and ISO and all of those. The AI so the AI, the enterprise risk management cannot fully understand those technical things. So it's both of us. And for governance, before anything, before we think, if there is no management support, if there is no management buy-in, no governance, nothing for whatever AI or whatever governance. If there is no management support, no architecture, no structure, no policies, there is no. You can't protect what you don't know. Yes, that's right. Thank you, Gismail. Explain slide 22 and 23. I think now we are out of our time limitation. If you could allow me, if you could review the video for this webinar, and if you have something else, you can convey it to me separately, and I would be happy to answer it again or clarify anything for any one of you. Thank you, gentlemen, for this quiet times I took from your time. Thank you. It is my honor to be with you this time, and I hope that I introduced something valuable for you. Assalamu alaikum wa rahmatullahi wa barakatuh.